All right, so the beginning of another wonderful day in Chico. How about questions? What do you got for me? What are questions on? Yeah, go ahead. The question is, do structure declarations work the same as function declarations? Yeah, they certainly serve the same purpose in that so let me actually create some code rather than just waving my hand at it. All right, so let me say here. Oh, what is a float? All right, so this code won't compile for two reasons. One is the compiler, I guess we could actually see what the compiler tells us. Whoops, declarations. I was looking at that thinking, why does that not look right when I originally declarations. Okay, so what the first problem we have is the compiler always has to know what it is before you're allowed to use it. That isn't true in all languages, by the way. This is very specific to C++ and C. I think Python is an example of a language where you don't have to tell the compiler about it before you use it. In fact, Python generally doesn't even have a compiler. But I digress. In C++, you have to let the compiler know what it is before you use it, and so that is the purpose of a structure declaration. Struct hero, and my hero may have several things. Looks like the way I'm using it there on line 12, we would assume that every hero you create has a weight. And on line 12, eating a bit of dessert there. I'll just leave it as that one to keep it simple. So that's sufficient for it to stop complaining about line 7. Now if I compile it again, it complains again, a similar complaint, that it doesn't know what add pi is. So we have to tell it what add pi is before we use it. Now note that I've actually defined the function down there on line 16, but the compiler goes from top to bottom. And going from top to bottom, when it hits line 12, it has never seen add pi before. So a function declaration is going to tell the compiler what the function is. So let me annotate these with comments. Now, let me confirm that I've eliminated my errors, and I have. So the question was regarding the similarity of structure declarations and function declarations, and the short answer is yes, they are the same thing, or they serve the same purpose, that they provide information to the compiler. They don't take up space, per se, meaning that if I create, so I can do, let me actually come here. What am I looking at here? So I've done a long listing. H means human readable. If I leave off the H, that gives me number of bytes. But I wanted something a little bit easier on the eyes. It's 4.2 kilobytes is what that executable occupies on my file system. If I were to go to line 4, say, and add about 10,000 other function declarations and another 50 structure declarations, and I recompile, and otherwise didn't change the code, all I did was create a bunch of declarations. I recompiled the code and I examined the executable size. The executable would be the exact same size. That's what I mean by they don't occupy space. They are merely information for the compiler to ensure that you use things correctly. Now what does occupy space is line 14. If I create a million different heroes, then my executable is going to increase substantially, right? Those are actual things in my application. But the declarations are just information for the compiler. So yeah, the short answer is the purpose of the declaration is the same for both functions and structures. Yes?
So I've seen like some examples or whatever of like people do declarations, but they don't name like variables in the declaration and only do it like later in the definition.
Meaning like for
They
functions?
They just have
like that?
Yeah.
Yeah. So that is absolutely correct. And let me repeat again before I go into that. The declaration is nothing but information for the compiler to ensure that if you decide to use it, you're not required to, that if you decide to use, in that case, the function declared on line 10, that you use it correctly. Now, what that's saying is, one, what does it mean for me to use it correctly? That means that the function name I provide is the same as that declared on line 10. The language is case sensitive, so I've actually described a totally different function that the compiler has never heard of, and that's what it says. I don't have the slightest idea what addPy is, right? So to use it correctly means that you spell it correctly, including the case. It also means that the information that you pass in is of the same type as described on the declaration. Note that I can call the addPy function by passing in 23.3. I can pass in this floating point number here. I can put in expressions. I can say 23.3 plus 88.883. That works because the system will add the numbers together and then the result of that expression will be passed in. This right here is not information the compiler needs to help you use it correctly. All it needs to know is that, one, there's only a single input parameter, and two, that single input parameter is of type float, right? So actually this right here is just for us as humans to be able to more clearly understand what the purpose of the function is, because this here may not even be in the same file. This may be in a totally separate file, and rather than cracking open that totally separate file and examining this, probably FL is a bad choice. So let's call this the, let me do this, the for dessert weight, right? Okay. Now that function makes a whole lot more sense. So let's set aside the fact that the function makes no sense at all, but you see what I'm saying is for human readers, you can provide useful information to help us understand the purpose of the function, but the compiler doesn't know or care. So that's perfectly fine as far as the compiler is concerned. The compiler just ignores whatever I put there. Other questions? The difference between class and struct. All right, so first of all, we will be working heavily with classes after the midterm for the balance of the semester. So I don't want to get into too far into the weeds yet about it. Let me give the general difference between them. A struct is intended to hold nothing but group together different kinds of data, right? And that's what the hero is. The hero is grouping together a float, which is their, I don't know, the amount of life that they have left, and maybe a string for the hero's name, and an integer for the waist size of the trousers that the hero wears, right? All those are variables that we want to shove together as one group that, in this case, describe a hero. So that's the purpose of a struct. The purpose of a class takes it a step further. It's partially to stick together a bunch of pieces of data that logically belong together in the context of our application, but it's also to group together functions that operate on that data. So an example that we'll look at early on is this idea of a date class, where a date is comprised of data, a day, month, and year, say 3 integers, but then there are also functions that operate on that date, like, I don't know, add a week to the date, right? There could be a function called add week, and then it's going to do some manipulation of the day and month. So for instance, if you're at October 28th, then it needs to change both the month and the day to get to a date early in November. So that would be a function that would be kind of wrapped up with that data. So that would be a class. A class is both data and functions. A struct is just data. And classes exist in C++. They don't exist in C. The C language is what introduced the struct to us, this idea of bundling data together. Other questions? Yeah.
Like in the project write-up, it says something about like saving your game. How would you write like a structure to like a file and then like read like the struct data into the program, you know?
Right. So for saving progress into a file and loading it, how would you deal with reading and writing the structure? You would do it exactly the same way as that lab where you're doing the movie data, except rather than, in the movie data, it's just 3 variables that get written out to the file, right? Or read in from the file. It's the exact same way with the structure. You would just be doing things like, if I use my hero here as an example, I'd have something like OF stream save file, whatever, adventure data dot text, and then I would just say save file chevron h dot wait end line. My hero is quite simple. I don't have anything else, so but it'd just be a sequence of lines like 21. And then you do the reciprocal for reading in. Other questions? One, in the design of the adventure, I thought it good for me to emphasize something. This would be your main function, and this would present the initial adventure information. It would ask you a set of choices. Do you want to, oh, let's see, I drew my circle prematurely. It'll prompt you, so do you want to, 1, go to the quarry? Do you, 2, want to, I don't know, climb the ladder? Good look on what the description of this adventure is. 3, mend your socks. All right. And me and my 2 teammates got together, and it was decided that I would write the query function. So this, if I choose 1, then it's going to call the TA Gibson function, passing in the hero. So this would be the TA Gibson function. And then one thing that there might be in my function is, so then I have to offer a couple choices, right? You're in the quarry. Do you want to, 1, drink the water down there? Or 2, you see a piece of string. Do you want to grab the string? So this is my function. And then the user will do either 1 or 2, and after they do 1 or 2, I can print the result, like you drink the water and you lose 10 health. So let me actually type this. So you have a struct. Let me see if I can actually change this to look computer-like. Struct hero. In this case, has an integer for the health, and the hero also has a Boolean for has string. And when you start the game, the health is, I don't know, the health is at 10, and the has string is false. So I'll put that up there for us to refer to. Oh, that's interesting. It didn't capture the curly braces. So what I might do is, if they drink the water, then I might say the heroes. I have some variable for the hero. Say H, being creative as I am. H dot health, my health minus equals 5. And if they grab the string, then I might hit H's has string equal to true. And I print a little message out, you know, you choke on the water. Here I say you grab the string, and then there's a return statement, and I return back to the main function, and I get these choices again. And so now the user chooses 3, and this goes out to PJ Smith's function, whoever that is, one of my many pretend friends. And PJ Smith gives a choice to, maybe he says blah, 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 there's a needle, grab needle. And choice 2 is to wring out socks and drink that water. And so if I choose 1, so then they choose 1. So for option 1, then I might have a statement like if heroes has string is equal to true, then I'll just put a comment here. Say socks mended. Otherwise, the string is false. You can say, well, you grabbed the needle, but you don't have any string, so you can't mend the socks, right? So you see, that's a nice, simple way to actually tie these rooms together. I can make your behavior affect what happens in a different room. Are you required to? No, not necessarily. Look at the grading rubric. I don't have any sort of fine detail like that in there. But just showing you that there's some relatively simple things you can do to create interaction around your adventure. The model here is hub and spoke, which means that I'm starting the main function. I go to someone's area, I return. I go to someone's area, I return. I go to someone's area, I return. I don't go to someone's area, go to someone's area, go back, because it just increases the complexity tremendously. So if you go with this model that you call TA Gibson's function, some stuff happens, you return back, this menu comes up, you go to someone else's function, stuff happens, you come back. If you go with that model, then I think that's going to be the simplest for you to implement. That makes sense? That useful?
So what's the best way to return back to main?
What's the best way to return back to main? Well, I think I asked that all the functions have something like hero, TA Gibson, hero, right? That's the function declaration that we were just talking about a few minutes ago. So how do you return back to the function? You just have a return statement with my variable h. I just say return h. And then main is going to say h equals TA Gibson h, where you can pass in h can be changed, and when it comes back, you grab the changed version in main. Anything else? Nothing there? Yes? No, it doesn't. So there are definite limitations. Now, you can trick this thing up to be bulletproof, but for instance, a thing to consider is I go to TA Gibson and I'm given a choice to drink the water or grab the string. So I grab the string and I trip that value to true. I return back to main, but then I go to the query once again, back to TA Gibson, and ask me, do you want to drink the water or grab the string? Well, hell, I've already grabbed the string, right? Now you can put logic in there. So you can say if they've already grabbed the string, then don't provide an option 2. Their only option is to drink the water again. But again, I think that's awesome and cool, but it's not complexity that I'm requiring. It all depends on your comfort level. Some people are just struggling with the idea of creating a function that compiles, much less making the thing make sense, right? So I'm with you there, and you have my blessing if you need to go simple. To the extent that this is interesting to you and you want to try and make it a little more robust, working on this kind of thing is one, but more fun, I would propose, than working on the hello world kind of stuff. And two, by virtue of working on it, you are actually studying for the midterm, right? Because your ability to pass this midterm is equal to your ability to just sit down and crank out code. And if it's hard and you're struggling and you're figuring things out, as long as you're learning stuff along the way, then your grade is going up with every hour you spend or every 10 minutes you spend on this project. Your grade on the midterm is likely to be going up with every amount of time you're spending on this project. Okay? Anything else? All right. So what I want to do is we still have some time left. Rather than me talking at you all period, I thought this would be a nice opportunity for you to get together with your group and further work on this. So I'm giving you a little bit of time for that. I do have one person who is without a group. Is there a group of 2 people, or is there a group of 3 where only 2 are here today? I see like a few of these Tyrannosaurus Rex hands. Someone tell me who fits in that category. All right, tell me your situation. A group of 2 or a group of 3 and there are only 1 or 2 of you? One, okay, so you're a group of 2 at this moment. Is that correct? What do you know what your group number is? All right. Then could you 2 come up here as soon as we break here in half a second? All right. Anything else? All right, go ahead and get in your groups. If I could get the group of 2 up here, and Mr. Bailey.